Hey everyone and welcome back. In the last series of One Shot, we discussed about continuity. In this session, we are going to talk about differentiability. And this is a one-shot video on differentiability. Make sure that you watch till the end because we are going to solve ample of problems and it is going to be fun. Okay, so let's begin. So what exactly is differentiability? That is differentiation. So if a graph has a sharp corner at a point, then the function is not differentiable at that point. Differentiable at that point means whenever you have a graph, I'll give you a random example. Suppose you have a graph like this and you have a point. Now tell me one thing, can you draw a tangent to this point? Yes, you can draw, right? So this will be the tangent. Can you draw a tangent over here? Yes, you can draw like this. Can you draw a tangent over here? Yes, you can draw like this. So whenever you have curve, so definitely tangent at that point is possible. So a function is differentiable at that particular point. But whenever you have a sharp corner, say something like this, in that case, you cannot draw a tangent, right? How will you draw a tangent? Tangent means what? Tangent is a line which intersects the curve at only one point. So here, clearly we can say that this is not differentiable, correct? Not differentiable. So always remember at one point, there is only one tangent. But if you see here, then all these lines will become tangents, no? There should be only one line. So this is not differentiable at x is equal to 0. So differentiable means the derivative exists at every point in the particular domain, right? Okay. The derivative measures the rate of change. So what exactly is derivatives? It is nothing but the rate of change or the slope of the tangent to the function at a given point. So there are two meanings of derivative. One is the rate of change. We're going to use the rate of change concept more in our application of derivatives chapter. And also the meaning of it is the slope of the tangent, as I told you, tangent to the curve. Slope of the tangent to the curve at a particular point. That is the meaning of derivative. So here we have a function and this line is a tangent to the function, correct? What is the tangent? Tangent is a line which intersects a circle, not necessarily circle, but any curve at only one point. Now this angle is theta. So this line is basically parallel to your x-axis, correct? So if this angle is theta, can I say this is also theta? Because we have studied this corresponding angles in our grade 9 as well. So differentiability implies continuity, but the reverse is always not true, correct? That is, if the function is differentiable, then it is definitely continuous. But if the function is continuous, it's not necessary that it is going to be differentiable. All right? Okay. So derivative of f of x is, so this is the formula and we have also studied this in the first principle, right? That is f dash of a. This is how you read it. The derivative of the function fx is f dash of a, limit h tending to 0, f of a plus h minus f of a by h, where h tends to 0, right? Now, if a function is differentiable at a point C, understand this. Whenever the function is differentiable, then it is also continuous at that point. So if the function is differentiable, it is continuous. Differentiable, then it is continuous. But the vice versa may or may not be true. If the function is continuous, it may or may not be differentiable. For example, there is a straight line, correct? For a straight line, can I say this is a continuous function? Yes, it is continuous. But is it differentiable? Can you draw a tangent here? You cannot draw a tangent there, right? So definitely this is continuous, but it is not differentiable. So every differentiable function is continuous. The function fx is equal to x cube. This is a differentiable function, hence it is continuous. And if you see the graph of x cube, it looks something like this, correct? So x cube looks like this. This is differentiable and it is continuous also. That means you can draw the tangent also, correct? Here it is, correct? Now let us see an example. So fx is equal to x square when x is greater than equal to 1 and fx is x when x is less than 1. Here we are supposed to show that f is not differentiable at x equal to 1, correct? Okay. So let us talk about the right hand derivative first. So limit x tends to 1 plus will be what? F of x minus f of 1 by x minus 1, correct? You're going to pick this because we're talking about 1 plus. So limit x tends to 1 plus x square minus 1 by x minus 1, fx is x square, correct? So if you solve this further, x minus 1 will be cancelled. And if you put x as 1 now here, you get the value of this as 2, correct? Now if I talk about the left hand derivative, that is limit x tends to 1 minus fx minus f of 1 by x minus 1. In that, again what you can do is, you can put x as your fx. Let us do that. So you get x minus 1 by x minus 1. You cancel x minus 1, cancel x minus 1. Ultimately, you're going to get 1. That is 1. So right hand derivative is 2. Left hand derivative is 1. Are they equal? They're not equal. Since they're not equal, we can say that this function is not differentiable at x is equal to 1. So the function is not differentiable. Correct? See. Simple. So the left hand derivative and the right hand derivative, both of them must be equal. Then only we can say that the function is differentiable, otherwise not. Okay. Let us see one more example. If f of x is x square, then what is f dash of x? Now, if you recall the formula, the first principle formula, we already know. What is that? The function is given x square. We are supposed to find out f dash of x, that is the derivative of that function. We know that f dash of a, here a is nothing but the derivative. F dash of a is nothing but the derivative of f of a. F dash of a is limit h tends to 0, f of a plus h minus f of a by h, right? So let us solve this. So that is going to be limit h tends to 0, correct? F of x plus h minus f of x by h. F dash of x is equal to what? Limit h tends to 0. This we already know. Please make a note of this formula. This is also called as first principle. F of x plus h minus f of x by h. Now see, fx is already given x square. Then what will be f of x plus h? It will be x plus h the whole square, isn't it? So we'll have x plus h the whole square minus fx. Fx is already x square here by h. Expand the bracket. You will get a square plus 2ab plus b square. X square will get cancelled. Now you can take h common. Correct? From here you can take h common. After taking h common and cancelling it with this h will get cancelled basically. You get 2x plus h. Now put h as 0. What will happen? You get f dash of x is equal to 2x. So f dash of x, you have already found out 2x. So we can say that the derivative of x square is 2x. You already know that directly, but just a way of solving, right? Okay, let's continue. Some standard differentiations now. We'll have all the formula. Please make a note of this. You can also take the screenshot of this because these formulae are going to be important in solving problems. So the derivative of e raised to x is e raised to x. The derivative of a raised to x is a raised to x log of a, where a is greater than 1 and a is not equal to 1. Derivative of log of x is 1 by x to the base e. So this is not natural log, this is base e. D by dx of log x to the base a is 1 by x log of e to the base a. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cosec square x. Derivative of cosec x is minus cosec x cot x. For sec x, it is sec x tan x, correct? And this is very important. Many times you're going to use this. Derivative of x raised to n is n x raised to n minus 1, correct? So all these formulae are going to be important for solving further problems, right? Okay. So we are supposed to differentiate 5 raised to x. Now see, you need to identify from here 5 raised to x. It looks like what? Can I say it looks like this? 5 raised to x, correct? A raised to x, exponential function. And we know that the derivative of a raised to x is a raised to x log a. So instead of a, you have 5. That's it. So here it is. We have 5 raised to x. So we will differentiate with respect to x. So you write it down like this: d by dx, differentiating with respect to x. d by dx of 5 raised to x. Correct? That is d by dx of 5 raised to x, of course. And the differentiation of this is nothing but a raised to x log a. That is 5 raised to x log 5. Simple. How did we get that? We got that from the formula that we have studied, right? Okay. Now differentiate x raised to 12. X raised to 12. So can I say this is like your x raised to n, and we have already seen the formula for x raised to n. X raised to n is nothing but n x raised to n minus 1, right? So here also we have x raised to 12, differentiate with respect to x, that is write down d by dx. D by dx of x raised to 12, n x raised to n minus 1. This is your n. So n x raised to n minus 1. So 12 x raised to 11. If you get x raised to 5, that will be 5 x raised to 4. X raised to 8, 8 x raised to 7. Like that. Simple. Now let us see some rules for differentiation. The first rule says that if you have any constant, say for example, k is a constant and u is a function that is differentiable, u is a differentiable function, k is some constant, then the derivative of k times u is same as k times the derivative of u. So basically that constant remains as it is. You keep it as it is there, just take the derivative of the function. Okay, we'll understand this with the help of an example, don't worry. So differentiate 8x cube. So what is k here? That your k is 8. Keep it aside. Don't do anything with it. Just focus on x cube. Correct? So we have 8x cube. X cube is how it looks like x raised to n. X raised to n is n x raised to n minus 1, isn't it? So we'll differentiate with respect to x. D by dx of 8x cube. Now see, that k is 8. So take that k outside. See here, k is outside. D by dx of x cube. X cube is what? X raised to n. That is 3x square. Correct? So 3x square. How square? 3 minus 1 is 2. Then 8 and 3 you can multiply. That gives you 24. That is going to give you 24x square. Simple. So don't do anything with that constant. Keep that constant as it is. And then you get the answer. Okay. Rule number 2. That is the addition or subtraction. Basic operations. So if you have two differentiable functions, f and g, then if you add the functions and then take the derivative, or if you subtract the function and then take the derivative, it is same as taking the derivative individually and then adding or subtracting them. Such type of questions we have also studied in limits, but that concept was of limits. Here we have derivatives, differentiation. So let us see an example. So differentiate sin x plus 9x. So sin x, 9x. So two differentiable functions, one is sin x, other is 9x, and we have addition in the middle. So differentiate separately and add them. Correct? So we'll say we have sin x plus 9x, differentiate with respect to x. So d by dx of sin x plus 9x. So d by dx of sin x plus d by dx of 9x. Separate that. See, d by dx of sin x, then d by dx of 9x. Basically, we are separating it. The derivative of sin x is what? The derivative of sin x is cos x. What is the derivative of 9x? 9 will remain as it is. What is the derivative of x? X is x raised to 1. So that is 1 x raised to 1 minus 1. That is 1 x raised to 0. X raised to 0 is 1. So always remember, derivative of kx is k. Derivative of 9x is 9. Derivative of 8x is 8. Correct? So yes, that's it. So sin x derivative is cos x. 9x derivative is 9. Simple. Okay. Let's continue. Now we have UV rule. UV rule means what? The product of u and v. Correct? But that does not mean you have to take the derivative of u, derivative of v and multiply them. Slightly different. Slightly different than addition and subtraction. UV rule states that if u and v are two differentiable functions, first of all, they should be differentiable. Then if you get the product, like I'll give a simple example, sin x multiplied by x or sin x multiplied by x square. So sin x is a differentiable function, x square is a differentiable function, sin x is u, x square is v. Then in that case, we have u multiplied by derivative of v plus v derivative of u. U derivative of v plus v derivative of u, or derivative of u times v plus u times derivative of v. Here is an example. Now say differentiate 2x multiplied by e raised to x. So 2x is one polynomial function, this entire 2x, and e raised to x is one exponential function. So you have a polynomial function, you have an exponential function, right? So let us move on to the solution. So we have 2x multiplied by e raised to x. We'll differentiate with respect to x. What will happen? Observe this. Firstly, that will be your u, e raised to x will be your v, correct? And 2 is your constant. You can also take 2x as your u, doesn't matter. So 2 is taken outside, x is your u, e raised to x is your v, correct? So 2 times d by dx of x e raised to x, that is like your uv rule now. So that becomes x multiplied by derivative of e raised to x plus e raised to x multiplied by derivative of x. U derivative of v plus v derivative of u. Simple. Solve this further. 2 is as it is. Derivative of e raised to x is e raised to x, and derivative of x is 1. Correct? So that becomes 2 times x e raised to x plus e raised to x. If you want, you can take e raised to x outside. That becomes 2 times e raised to x multiplied by x plus 1 inside the bracket. Correct? Yes. This can be your final answer. I hope you're understanding how to use the product rule here. Clear? Okay. So we have one more question on the product rule. No problem. So here we have cos x multiplied by x cube. Cos x multiplied by x cube. So cos x is your u, x cube is your v. Correct? Then u derivative of v plus v derivative of u. Let's continue. So here we have, we'll differentiate with respect to x, that is d by dx of cos x multiplied by x cube. So cos x is your u, x cube is your v. Correct? Clear? So that will become d by dx of cos x multiplied by x cube. So u derivative of v plus v derivative of u. Cos x is as it is, x cube is 3x square. X cube will be as it is, derivative of cos x will be minus sin x. Let us do that. See here, cos x as it is, derivative of x cube is 3x square. Correct? Then the derivative of cos x is minus sin x. So you can see you have minus, you have sin x, and x cube is as it is. Simple as that. Let's continue. Okay. So you can solve this further, of course, because you can take x square common from here, and then inside the bracket you have 3 cos x minus x into sin x. This is not e raised to x, this is sin x. Okay. Rule number 4. This rule is called as u by v rule. U by v. Fine. So it says that if you have u and v as the two differentiable functions, so u and v are differentiable functions, then how do we find out the derivative? U derivative of v minus v derivative of u by v square. U derivative of v minus v derivative of u by v square. So we have sin x by x. Correct? So this is your u, this is your v. Correct? See here. Now understand. How do we solve this? You can see here, v derivative of u. We'll write down v, that is denominator. Derivative of u minus u derivative of v by v square in the denominator. I hope this part is clear. So just solve this. You're going to get x as it is. Derivative of sin x is cos x. Sin x is as it is. Derivative of x is 1. So we have not written anything here. And then we have in the denominator x square. That's it. Now let us talk about the chain rule. Now suppose f is a real valued function which is a composite of 3 functions. So f is a composite of three functions, u, v and w. Then if say we have t as v of x and s as u of t, then df by dx will be equal to dw by ds times ds by dt times dt by dx. So if you see overall, the result remains the same. So there is no change. By the way, this is not df, this is dw. Because see, we are breaking it into parts, no? dw by dx. dw dx is there, ds, dt, dt goes. Doesn't matter. So we find out dw by ds, we find out ds by dt, we find out dt by dx. Now see here, there is a function given fx is equal to sine of natural log of x square plus 1. So sine of natural log of x square plus 1. Now sine is your first function and log is your second function, correct? And x square plus 1 is your third function. So we have sine also, we have log also, we have x square plus 1 also. So we have trigonometric function, we have logarithmic, we have polynomial. So here the functions are combined. So this can be expressed as, say, df by dx is equal to df by du times du by dv by dv by dx. Overall result is nothing but df by dx only. We are finding out df by dx only, correct? So firstly, let fx be sine u, where u is this part. So this entire part is u. So fx will be equal to sine u. Now we'll differentiate sine u with respect to u. We're focusing on this part. We'll differentiate sine u with respect to u. So can I say sine u will be nothing but cos u. Derivative of sine x is cos x. So that becomes cos u du by dx, correct? This is differentiating sine u with respect to x. Now we'll take u is equal to ln of v, where v is nothing but x square plus 1. So dv by dx is nothing but 2x, because the derivative of x square is 2x, correct? And du by dx will be 1 by v. Derivative of log x is 1 by x, correct? So further, if we combine this, we have f dash of x is equal to 2x by x square plus 1 multiplied by cos x natural log of x square plus 1. So this is the final answer. This is how you can find out the answers using chain rule. Now again, we have log of sin x e raised to x. Log of sin x e raised to x. So we have log, we have sin x, we have e raised to x, right? So let this part be u. So this becomes log u, right? So u is what? U is x times e raised to x. So if I differentiate this with respect to x, I get du by dx is equal to, now this is your product rule, isn't it? In product rule, you know how to solve this. U derivative of v plus v derivative of u. So that becomes sin x derivative of e raised to x plus e raised to x derivative of sin x. This becomes sin x into e raised to x plus e raised to x into cos x. And derivative of e raised to x is e raised to x only. This is du by dx, right? Now what will be dy by du? Dy by du here, because y is in terms of u. So differentiating with respect to u, dy by du, this is log u, correct? This is log u. That will be 1 by u, isn't it? That is 1 by u, but u we already know. See, everything is connected here. U is already here. I hope this part is clear. That is dy by du. And then dy by dx will be what? Dy by dx will be dy by du times du by dx. We have both the values. Just substitute there. So dy by dx will be equal to 1 by sin x into e raised to x. And du by dx is over here. So once you solve this further, do some cancellations, of course. E raised to x will get cancelled. And then finally you get 1 plus cot x, because e raised to x will come outside. This will go. Sin x by sin x will become 1. And cos x by sin x will become cot x. So you know how to solve that. That's not a problem, right? Okay, let's continue. Now we have a new question. It says y is equal to log of sin e raised to x. Then we are supposed to find out dy by dx. So this part, correct? Sin e raised to x. So you can take that as u. So y will become log u. correct? So dy by du will be 1 by u. Now let v be e raised to x. So dv by dx is e raised to x because the derivative does not change, same thing. And u is what? U is sine v. So du by dv will be cos v. Now we have all the values, right? So here can I say dy by dx is dy by du times du by dv by dv by dx. Just put the values there, correct? V is e raised to x and u is sine e raised to x. So that becomes e raised to x cot e raised to x. I hope this part is clear. Very simple. 3 times we have to do that and then multiply. That's it. Okay. Let us see one more example now. Differentiate e raised to tan inverse x square. Okay. Now again, what we can do is this part, this portion, tan inverse x square. Correct? This is e. That is your first function, exponential, tan inverse. That means we are talking about inverse function, second function, and x square, third function, which is a polynomial function, right? So let tan inverse of x square be u. The entire tan inverse of x square, this part, is your u, correct? So y will be equal to, or fx will be equal to e raised to u. Now you can differentiate. If you differentiate with respect to x, e raised to x, e raised to u will be e raised to u du by dx, right? Now, u is what? Your u is tan inverse x. So what will be du by dx? Du by dx is going to be 1 by 1 plus x raised to 4 2x. Why? Because we know that the derivative of tan inverse of x is nothing but 1 by 1 plus x square and the derivative of x square is nothing but 2x. So derivative of x square is 2x, derivative of tan inverse x is 1 by 1 plus x square. But because we have x square already there, that becomes x raised to 4. Clear? Now we have f dash of x, that is e raised to tan inverse x square multiplied by 2x by 1 plus x raised to 4. I hope this part is clear to all of you. Right? Okay. Now we are supposed to differentiate fx is equal to cos cube under root x square plus 4. So again, same thing we are going to apply. Applying chain rule, this is what we are going to get. See, this is cos cube x under root x square plus 4. So this is like your x cube, right? So x cube is what? 3x square. So 3x is your cos itself, cos square under root x square plus 4. And then you take the derivative of cos under root x square plus 4. That is minus sine under root x square plus 4. And then you take the derivative of under root x square plus 4. Basically, you are applying x raised to n first over here. This is x raised to n. Then you are applying cos of this. And then you are applying only for the inner bracket. That's it. So that gives you minus 3 cos square under root x square plus 4. This is sine, and of course the minus sign is outside here. And what is under root x? The derivative of under root x is 1 by 2 root x. So this becomes 1 by 2 root x square plus 4. And what is derivative of x square? Derivative of x square is again 2x in the next step. So this 2x and 2 will get cancelled. And then you get x by under root x square plus 4. Correct? And this is how you solve. I hope this question is clear to all of you. Now let us talk about the derivatives of implicit functions. So an implicit function is a function where the dependent variable, so y is a dependent variable, is not isolated explicitly in terms of the independent variable x. So let us see an example. So here we have x square plus y square is equal to 1. In such cases, the derivative is found by differentiating both sides of the equation with respect to x. So we'll differentiate both sides with respect to x, applying the chain rule if necessary, of course. So what are the steps involved in the implicit function? The first step is differentiate both sides of the equation with respect to x. Then apply the chain rule wherever it is needed, especially when you have a function like this y is equal to y of x. And collect all the terms containing dy by dx on one side. So we'll keep dy by dx on one side and all the other terms on the other side because we actually want to find out dy by dx, isn't it? And then solve for dy by dx, that's it. So here we have x square plus y square is equal to 25. X square plus y square is equal to 25. So how are we going to start? We are going to start by differentiating both sides with respect to x. This side also we are going to differentiate with respect to x. This side also we are going to differentiate with respect to x, right? Now see, what is the derivative of x square? The derivative of x square is 2x because that is x raised to n x raised to n minus 1. But what is the derivative of y square? Derivative of y square is 2y. But since we are doing it with respect to x, that will be 2y dy by dx. And derivative of 25 with respect to x, with respect to anything, that will be 0 only. Now just keep dy by dx on one side. And 2 gets cancelled after taking common. X will go on the other side. So dy by dx is equal to minus y by x, right? And that is how you find out the derivative of the implicit function, correct? Okay. Let us see one more example. Again, we have an example of implicit function, but again, here if you see, we have sine of x plus y, right? Okay. We'll differentiate with respect to x, no worries, on both the sides. So dy by dx, sine x will become cos x, but we have sine x plus y, so that will become cos x plus y, right? That will become cos x plus y, this part, but again we have x plus y, right? We need to take the derivative of that. Derivative of x is 1, derivative of y with respect to x is dy by dx, correct? And here, derivative of x square is 2x, derivative of y square is 2y dy by dx. So cos of x plus y plus cos of x plus y dy by dx is equal to 2x plus 2y dy by dx, isn't it? You solve this further, right? Keep dy by dx on one side, rest all the terms on the other side. And that is how you find out dy by dx. So once you get dy by dx on one side, all the other terms on the other side, do some operations if that are possible. If not, keep it as it is. That will be your final answer. Nothing new in that. I hope this is clear. Okay. Let us see one more example. It says find dy by dx for the equation x cube plus y cube minus 3xy is equal to 0. Very simple question. On the right hand side, anyways it is 0. On the left hand side, you have x cube plus y cube minus 3xy. So obviously, same logic we are going to apply here. Firstly, we'll have the derivative of x cube, which is 3x square, derivative of y cube, 3y square, dy by dx. And then this is your product rule, u derivative of v plus v derivative of u. Let us see how does it look like. You can see here. Let's differentiate. This is 3x square. This is 3y square dy by dx. 3 as it is. In fact, minus 3 as it is. U derivative of v plus v derivative of u. Simple. Is equal to 0. Now solve this further after opening the bracket. We are opening the bracket here. Now we can take dy by dx common, right? So once you take dy by dx common and shift all the terms on the other side, what is going to happen? You're going to get this. And that's it. That is your final answer. If you want to take 3 common, you can take 3 common from the numerator and the denominator. Once you take 3 common, 3 gets cancelled. You get x square minus y by x minus y square. That is your final answer. I hope this is clear to all of you. Let us see one more example. If cos of xy is equal to k, where k is a constant and xy is not equal to n pi, where n belongs to the set of integers, then what is dy by dx equal to? It's a simple question. Cos of xy is equal to k. Cos of xy is k, correct? So obviously we need to differentiate on both the sides with respect to x first. And this is xy. Don't forget we are going to apply product rule also there. So d by dx of cos of xy is equal to d by dx of k. Derivative of constant is 0. Cos becomes minus sign, but xy is the product rule. X derivative of y plus y derivative of x. Derivative of x with respect to x is 1. And derivative of y with respect to x is dy by dx. Minus sign xy will go on the other side. That will become 0. Correct? If you want to open the brackets, you can open the bracket. Doesn't really matter. Solve it further. And ultimately, the final answer that you are going to get is minus y by x. We can get it directly also if you see. The previous slide, I'll explain how. This part goes on the right hand side. That becomes 0. So this is gone. You have x dy by dx plus y. Y goes on the other side. that becomes minus y. X dy by dx is equal to minus y. X goes down, dy by dx is equal to minus y by x. Clear? Now let us see one more example. Here you have, if x square plus y square the whole square is equal to xy, then find dy by dx. Simple question. Now see, if you see here, x square plus y square the whole square. This is a plus b the whole square, that is a square plus 2ab plus b square. So if I expand this, I get x raised to 4 plus y raised to 4 plus 2 x square y square, isn't it? Let us do that. Let us expand that. So we get x square plus y square the whole square is x raised to 4 plus y raised to 4 plus 2x square y square is equal to xy. Now we will differentiate both sides with respect to x. Take the derivative correctly. X raised to 4 becomes 4x cube. Y raised to 4 becomes 4y cube dy by dx. Now 2 will remain as it is. You will apply product rule here inside, and here also you will apply product rule on the right hand side. I hope this part is clear. It will be lengthy, but the procedure remains the same. We are just applying UV rule there, nothing much. Now solve this further. Once you solve, this is how you get after opening the brackets, of course. Nothing we have done, we have just opened the brackets, don't worry. And then we get dy by dx 4y cube plus 4y square minus x is equal to y minus 4x cube minus 4xy square. Just drag the bracket to the right hand side in the denominator and you get your final answer. So if there are any cancellations, do it. If there are no cancellations, keep this as your final answer. So this is your final answer. Now let's move on to a new topic, that is derivatives of inverse trigonometric functions. So how many inverse trigonometric functions do we have? 6. Sine, cos, tan, cot, sec, cosec, right? Inverse of those. So sine inverse of x, derivative of sine inverse of x, 1 by under root of 1 minus x square. For cos inverse x, minus 1 by under root 1 minus x square. Tan inverse x, 1 by 1 plus x square. Cot inverse x, minus 1 by 1 plus x square. Sec inverse x, 1 by x under root x square minus 1. And cosec inverse x, minus of 1 by x root x square minus 1. Now C stands for change of sign. Always remember. C stands for change of sign. So wherever you find C, you can see there is minus. That is how you can remember, basically, nothing much. C is change of sign. So in this way, you can change the signs whenever you have C, so that you don't forget. Rest formula remains the same. You should know this formula so that we can solve the problems based on this. So here we go. We have the first example. We have y is equal to sine inverse of 2x. Then find dy by dx. Sine inverse of, it's not x, it's 2x. So this 2x can be considered as x. What is the derivative of sine inverse of x? 1 by root of 1 minus x square. Correct? So here, if I want to find out the derivative of sine inverse of 2x, I'll have 1 by square root of 1 minus 2x square. Correct? Which becomes 4x square. 2 square is 4, right? And then I take the derivative of 2x separately, because I've treated this as x. I've not treated this as 2x directly. Correct? So that becomes 2. So ultimately, derivative of 2x is 2. And the denominator remains as it is. And that is your final answer. I hope this part is clear. If this was 3x, here you would have got 9x square. And here you will have 3x. Now let us have a look at one more example. It says if y is equal to tan inverse of 2x by 1 minus x square, then find dy by dx. In such cases, always remember you have to do substitution. If you recall the formula in trigonometric functions we have studied, that 2 tan theta by 1 minus tan square theta is tan 2 theta. So try to make tan 2 theta inside the bracket. But that is only possible when you put x as tan theta. Correct? So if I put x as tan theta here, what will happen? I'll get tan inverse of 2 tan theta. Wherever x is there, you have tan theta. Wherever x is there, you have tan theta. And this entire part becomes tan 2 theta. Correct? So tan inverse and tan gets cancelled. You get y is equal to 2 theta. Y is equal to 2 theta. Now understand. But if you see over here, can I say theta is nothing but tan inverse x? Observe this. If x is tan theta, can I say theta is tan inverse x? So instead of theta, I have tan inverse x. That's it. Just find out the derivative now. Y is equal to 2 tan inverse x. Keep 2 outside. Derivative of tan inverse x is 1 by 1 plus x square. So that becomes 2 multiplied by 1 by 1 plus x square, that is 2 by 1 plus x square. Clear? I hope this part is clear to all of you. Let's continue. Now here we know that 2 tan inverse x is nothing but tan inverse of 2x by 1 minus x square. So we could have done it directly also. That is one of the ways of doing it. And that you get 2 by 1 plus x square. Correct? Alright. Now let us see an example, very simple question. There is nothing much. Derivative of tan inverse x plus derivative of cot inverse x. And this was asked in the boards as well. See, very simple question. We already know the formula. We'll differentiate both sides with respect to x. So y becomes dy by dx. This is d by dx of tan inverse x. This is d by dx of cot inverse x. So we can separate them. This becomes 1 by 1 plus x square. This becomes minus 1 by 1 plus x square. Cancelled, isn't it? We'll get 0. Obviously, both the terms are getting cancelled there. Right? Very simple. And of course, very interesting. Tan inverse x plus cot inverse x is what? Pi by 2. So pi by 2 is what? It is just a number, no? Just a real number pi by 2. And derivative of a constant is always 0. So obviously it had to be 0, right? Okay. Now the derivative of e raised to x with respect to x is e raised to x only. Derivative of log x is 1 by x. Let us see some examples based on exponential and logarithmic functions as well. So here we have, if y is equal to e raised to 9x, then find dy by dx. Y is what? E raised to 9x. We are supposed to find dy by dx. Now this is exponential, right? Instead of e raised to x, you have e raised to 9x. So that will remain e raised to 9x only, but you take the derivative of 9x as well. So this becomes d by dx is equal to e raised to 9x multiplied by d by dx of 9x. That is 9. So 9 e raised to 9x. That's it. Simple. Very simple. Let's continue. Y is equal to e raised to under root cot x. Again same thing. Derivative of e raised to x is e raised to x only. So here also it will become e raised to under root cot x. But you have to separately take the derivative of under root cot x. Now under root cot x. Again cot x is like your x. What is the derivative of under root x? 1 by 2 root x. So again do that. So that becomes 1 by 2 root x, which is 1 by 2 root cot x. But cot x is pending. So take the derivative of cot x again, which is minus cos x square x. And then this is your final answer. So understand, e raised to under root cot x was there. Under root cot x is your x. So derivative of e raised to x is e raised to x. But under root cot x is remaining. Now under root cot x is again like your under root x. That is 1 by 2 root x. That is 1 by 2 root cot x. Again cot x is remaining. Take the derivative of cot x. That is minus cos x square x. So that is how you solve this. Clear? Now here we have one more example based on logarithmic functions. So whenever you have questions based on logarithmic functions, what you need to do is you need to take the log on both the sides, because applying UV rule over here becomes very tedious, right? So you'll take log on both the sides so that this exponent comes down, because we know that log of a raised to x is x log a, log of a raised to 4 is 4 log a, log of a raised to 10 is 10 log a, and so on. So here you have y is equal to x square plus 1 multiplied by x minus 3 raised to 4, correct? So you can take log on both the sides. So can I say this becomes log y is equal to log of x square plus 1 multiplied by x minus 3 raised to 4. Now log of mn, log of m multiplied by n. What is that? Log of mn is log of m plus log of n. So this becomes log of x square plus 1 plus log of x minus 3 the whole raised to 4. See here. Now you differentiate with respect to x. That becomes easy. So log y, derivative of log y is 1 by y. With respect to x, it is dy by dx is equal to log of x square plus 1, that is 1 by x square plus 1. Derivative of x square plus 1 is 2x. Then 4 log x minus 3. Log of x minus 3, derivative is 1 by x minus 3. 4 remains as it is. Correct? So you take y on the other side and then replace y. Replace y with your original y now. So this is how it looks. This is your y. And this part is already here. Okay, let's continue. Now let us see an example. If y is equal to x square plus 3x minus 5 raised to 7 by 2x minus 1 raised to 3. Again see, this is in the form of division. So if you take log on both the sides, we know that log of a by b is log a minus log b, right? Same thing will apply here. Taking log on both the sides, this will become log a minus log b. So see how it looks now. So log a and 7 was in the exponent form. That becomes 7 log this part, and here also this becomes 3 log bracket. Now it's very simple, take the derivative on both the sides. So if you differentiate on both the sides with respect to x, log y becomes 1 by y, dy by dx, 7 remains as it is. Log of x, derivative is 1 by x, take the derivative of the bracket part. Here also 3 remains as it is. Take the derivative of this, that is 1 by 2x minus 1, and the derivative of 2x is 2. That is why we have multiplied by 2. Solve it further. And then transpose the y to other side. Once you transpose y to the other side, this entire part is your y. And this part is already here. That's it. That is your final answer. Very simple, right? Okay. Now we will see the derivative of logarithmic functions. In that, obviously, we are going to see some examples. So if y is equal to x raised to x, then find dy by dx. Now understand, y is equal to x raised to x. So whenever you get something in the form of exponent, take log on both the sides. That is the first thing that you do. So what we will do is, we'll take log on both the sides. So taking natural logarithm on both the sides, we get natural log of y, that is log y is equal to x times log x. Why? Because log of x raised to x. This will come down x log x, right? Now what we can do is, we can differentiate on both the sides with respect to x. So once you differentiate on both the sides with respect to x, log y, derivative of log y is 1 by y. With respect to x, derivative of y is dy by dx. Then this is like your product rule, x multiplied by log x. So x, derivative of log x plus log x, derivative of x. And you know what is the derivative of log x, right? It is 1 by x. You also know what is the derivative of x, right? It is 1. So further, 1 by y dy by dx will be equal to x 1 by x plus log x times 1. So x and x will get cancelled. So you'll get 1 by y dy by dx is equal to 1 plus log x, and y will go on the right hand side. So that will become dy by dx is equal to y times 1 plus log x. But what is y? Y is x raised to x. So put x raised to x there, and that is your final answer. So I hope this is clear to you. Let us continue. Now we're going to talk about the derivatives of parametric functions. Now suppose there are two functions, say x is equal to f of t and y is equal to g of t. The derivative of y with respect to x. See, x is f of t and y is g of t. Still we can find out the derivative of y with respect to x. And how do we do that? We do it like this. Dy by dx is equal to dy by dt by dx by dt. Now we'll see how to find out the derivative of the parametric functions. Okay. So the first step is find dy by dt. That is differentiate y with respect to t. Correct? Then find out dx by dt. That is differentiate x with respect to t. Find dy by dt. Find dx by dt. Then just divide both of them. So find dy by dt by dx by dt. That gives you dy by dx. Okay, now let us see an example. So x is sin t and y is cos t. Simple question, right? X is sin t, y is cos t. Firstly, we will find out dx by dt. Then we will find out dy by dt. Then dy by dt by dx by dt. That is your final answer. Let us see. So x is sin t, y is cos t. So dy by dt, that is derivative of y with respect to t, will be minus sin t. Derivative of x with respect to t, derivative of sin t will be cos t. Dy by dx will be what? Minus sin t by cos t. And sin by cos is what? Sin by cos is tan. You get tan t, but minus. Simple? Okay, let's continue. Now, if x is equal to log of t, natural log, and y is equal to t square minus 1, find dy by dx. Same thing again. Nothing new. Firstly, we'll differentiate y with respect to t. Then we will differentiate x with respect to t. Then divide. So here it is. Derivative of t square is 2t. Derivative of minus 1 is 0. So we don't have anything. Derivative of log t is 1 by t. Now dy by dt, dx by dt, just divide both of them. So you get dy by dt by dx by dt to get dy by dx. So 2t by 1 by t, t will go up, that will become 2t square, and that's it, 2t square, right? Okay, let's have a new example. Now, slightly complicated example, but interesting. X is given e raised to t sin t, y is given e raised to t cos t. We are supposed to find out dy by dx at the value of t as pi by 4. Okay, forget about that. Let us focus only on applying the parametric functions, that is dy by dt and dx by dt first. This is already given. So dy by dt. But these are two different functions, isn't it? So we'll have to apply product rule. So can I say, okay, we'll find out dx by dt first. Doesn't matter. Same thing. Dx by dt. Product rule again. U derivative of v plus v derivative of u. So that is further equal to e raised to t, derivative of sin t is cos t, sin t as it is, derivative of e raised to t is e raised to t. This is dx by dt. Now let me talk about dy by dt. So what will be dy by dt? Dy by dt will be u derivative of v plus v derivative of u. So this will become minus sin t and this will remain e raised to t. See, minus sin t, derivative of e raised to t is e raised to t. If you want, you can take e raised to t common. Now we will take dy by dt by dx by dt, right? So e raised to t will get cancelled. You will get this. Now it's very simple. T is given as pi by 4. So all you need to do is put the value of t as pi by 4. So at pi by 4, this will become minus sin pi by 4 plus cos pi by 4 by cos pi by 4 plus sin pi by 4. Pi by 4 is how much? 45 degrees. 1 by root 2 for both, right? So that will become minus 1 by root 2 plus 1 by root 2 by 1 by root 2 plus 1 by root 2. But anyways, this will get cancelled and you get 0 in the numerator. No need to solve the denominator. The final answer that we get is 0. So 0 is the final answer. Clear and simple. Let us continue. Okay. Again, interesting question. The value of theta is given pi by 3. X is equal to a sec theta. Y is equal to b tan theta. Now, what will you differentiate this with? Obviously, you differentiate with respect to theta, right? Previously, it was t. So, we differentiated with respect to t. So, this will become dx by dt after taking the derivative. This will become dx by d theta. That will become dy by d theta. Dy by d theta by dx by d theta. That will give you dy by dx. Correct? Okay. So, here it is. So, dx by d theta. A is a constant as it is. Derivative of sec theta is what? Sec theta tan theta. Y is equal to b tan theta, right? So, b is as it is. Derivative of tan theta is sec square theta. Now divide both of them. When you divide dy by d theta first by dx by d theta. So this becomes dy by dx is equal to dy by d theta. This is theta, not dt. Dx by d theta. So this becomes b sec square theta by a sec theta tan theta. So this will get cancelled. You get b sec theta by a tan theta. You can convert this in sine and cos. Obviously, cos will get cancelled, and this is what you will get. Once you get this, you have theta is pi by 3. Put theta is pi by 3. Sine 60 degrees is root 3 by 2. So that will become b by a root 3 by 2. 2 will go up. That will become 2b by a root 3. Simple. Now we will see a new concept, that is higher order derivative. In higher order derivative, you have up to second order derivative only, right? First order derivative you already know. Now see, if y is equal to fx, then this is called as the first order derivative. That is, you take the derivative only once. Dy by dx is equal to f dash x. Now, this is the first order derivative. That is, you are taking the derivative only once. Now, if you take the derivative again of dy by dx, that will be your second order derivative. So, if f dash of x, fx is differentiable, you took the derivative, you got f dash of x, that should also be differentiable. If that is differentiable, we can differentiate it one more time with respect to x, and then that will become f double dash x. This becomes f double dash x. And how do we write it down? We write it down like this: d by dx of dy by dx. And this is nothing but d2y by dx square. That is the second order derivative. So d2y by dx square is nothing but you have taken the derivative 2 times. Simple. And it is also written as f double dash x. If you take derivative one more time, that will become third order derivative, right? d3y by dx cube and so on. So you have questions up to second order derivative only. This is third order and so on. Fine. Let's continue. Let us see an example. How do we actually find out the second order derivative? It is very simple. So the question says find third order derivative. This is just a random example, third order derivative of 6x square. So firstly, y is equal to 6x square. Firstly, we'll take the derivative, that is dy by dx. So differentiating with respect to x, dy by dx will be what? 12x, because 6 is as it is. Derivative of x square is 2x. 6 into 2 is 12, 12x. Now we will take the derivative one more time, that is d by dx of dy by dx. We know that the derivative of kx is k. So d2y by dx square will be 12. Derivative of kx is k, only the constant. Now there is just a constant. If you take the derivative one more time, you get d3y by dx cube as 0. Because the derivative of a constant, derivative of any constant or any number is 0. So this is how you have taken the third order derivative, just for your understanding. Okay. So we have some problems based on finding the second order derivative. Let us see an example. So find the second order derivative of the function. I'm very sure you can do this on your own. The function fx is given. Firstly, we'll find out f of x. Then we'll find out f double dash x, right? So fx is given. We'll calculate the first order derivative, that is f dash x. That is simple. X cube becomes 3x square. X square becomes 2x. 6x will become 6. Derivative of minus 3 is 0. And the constants remain as it is, like 4 will remain as it is. Minus 5 will remain as it is, right? Solve this. So f dash of x is 12x square minus 10x plus 6. Now we will take the second order derivative, that is f double dash x. So f double dash x is going to be, this becomes derivative of x square is 2x. So 24x. Derivative of 10x is 10, but minus sign is already there. Derivative of constant is 0. So we have not written anything here. That is plus 0 only. Doesn't matter. And yes, that's it. And if they tell you to find out the third order derivative here, the derivative of this will be 0. The derivative of 24x will be 24. Clear? Okay. Let's continue. Now we have second type of problems. That is problems based on finding second order derivative of parametric functions. Correct? So dy by dx is equal to what? Dy by dt by dx by dt. And then if I want to find out the derivative once again, d2y by dx square will be d by dx of this, isn't it? So that gives me d by dt of dy by dt by dx by dt times dt by dx. Ultimately, it's the same thing. It's d by dx only. So d by dt of this and then dt by dx. Let us see an example. Now see, firstly it is given x is equal to t square. It is given y is equal to t cube. You know how to solve parametric functions, right? So x is t square. If I take the derivative, can I say differentiating x with respect to t, dx by dt is 2t. This is done. If I talk about y is equal to t cube, can I say dy by dt is equal to 3t square, because derivative of t cube is 3t square, correct? Now, we have taken dy by dt, dx by dt. Let us find out dy by dx first. That is this divided by this. So that becomes 3t square by 2t. T will get cancelled. You get 3 by 2t. Now you take the derivative once again. So you can see here, the second order derivative will be 3 by 2 dt by dx, isn't it? So can I say this is as good as 3 by 2, 1 by dx by dt? But what is dx by dt? Now understand. See here, dx by dt is 2t. So, and this is like, this goes down 1 by dx by dt. So this becomes 1 by 2t. And that becomes 3 by 4t, isn't it? I hope this part is clear. This is very important. Easy? Okay. Let us see an example now. We have 5 cos x minus 3 sin x. We are supposed to find out the second order derivative, that is d2y by dx square. Firstly, let us focus only on finding dy by dx. So what is dy by dx here? 5 as it is, derivative of cos x, minus 3 as it is, derivative of sin x. Constants we will keep it outside. Derivative of cos x is minus sin x, derivative of sin x is cos x. So you get minus 5 sin x minus 3 cos x, minus sign common, 5 sin x plus 3 cos x. Now you can take the second order derivative directly here, correct? So take the derivative once again. Minus will remain as it is. 5 is as it is. Sin x becomes cos x. 3 is as it is. Cos x becomes minus sin x. Take this minus sign here. So minus sign is outside. 1 minus sign is inside. And that is your final answer. If you want, you can open the bracket as well. You get plus 3 sin x minus 5 cos x. That can also be considered as your final answer. Okay. And then if you see, 5 cos x minus 3 sin x is over here. You can replace that with y. Simple. See, here you have 5 cos x minus 3 sin x. Here also you have 5 cos x minus 3 sin x. There is a minus sign outside. So d2y by dx square is equal to minus y. Clear? Okay. Now successive differentiation, what is that? So successive differentiation is the process of differentiating a function successively for n number of times. And the result of such differentiation is called as successive differentiation or the nth order differentiation. Second order, third order, fourth order, fifth order, and so on, right? Now, how do we find out the nth or nth order derivative? So, step one is use simple differentiation to find first, second, third. You know how to find out the first order derivative, second order derivative, third order derivative, and so on. And then you observe the changes in the coefficients, the angles, the powers of the functions. This you'll get to know once we see the examples basically. How do we observe the changes there? Okay. And step 3 is express the nth derivative with the help of the patterns of changes that you have observed. So whatever pattern we are observing, we'll change it accordingly and then find out the nth order derivative of the given standard functions. We'll see an example as well. So see here. So this is the nth order derivative of x raised to m. So that is m factorial x raised to m minus 1 by m minus n factorial, right? If m is equal to n, this is the condition. Derivative of a constant is 0. Here if m is 0, that will become a constant. This is the derivative, nth order derivative for 1 by x or 1 by ax plus b. And this is the derivative of log x, that is the nth order derivative of log x. So please make a note of this. We are directly going to use this in solving problems. For sin x, it is sin n pi by 2 plus x. For cos x, it is a raised to n cos of n pi by 2 plus ax plus b, provided here you have ax plus b. If you have x here, this is going to be x. Okay. This is for sine. Now let us see an example. Find the nth order derivative of 1 by 5x plus 3. So we are supposed to find out the nth order derivative of 1 by 5x plus 3. So y is already there, 1 by 5x plus 3. So we will compare this with what? 1 by ax plus b, isn't it? This is of the form 1 by ax plus b. That gives you minus 1 raised to n factorial a raised to n by ax plus b the whole raised to n plus 1. So let us do that. Here, what is a? Your a is nothing but 5 and your b is nothing but 3. So let us put the values there. Put all the values of a and b here. Observe. Wherever you have a, that is 5. Wherever you have b, that is 3. And that's a simple example. Now let us see one more. Find the nth order derivative of cos of 2x plus 1. This is like cos of ax plus b, isn't it? Okay. So this is cos of ax plus b. And we know the derivative of cos of ax plus b, the nth order derivative, a raised to n cos of n pi by 2 plus ax plus b. A is to b is 1. See, a is to n, b is 1. So wherever you have a and b, just put 2 and 1. So yes, this is what you get. I hope this is clear to all of you. Instead of a, we have 2. Instead of b, we have 1. Now this is a very interesting question. Observe this very carefully. We have y is equal to under root of cos x plus under root of cos x plus. So this is getting into loop. We are supposed to prove that dy by dx is equal to sin x by 1 minus 2y. Now see, this is y is equal to under root of cos x plus, if you see this loop is repeating, right? Can I say this itself is y? So what will happen here? If I focus on that part, only this part, this is y, no? Under root of cos x plus till infinity. So this becomes y. Now y is equal to under root of cos x plus y. You can solve this further. Squaring on both the sides, y square is equal to cos x plus y. So if you differentiate on both the sides with respect to x, this becomes y square is 2y dy by dx. Cos x becomes minus sin x. Y becomes dy by dx. Take dy by dx terms together. Take dy by dx common. You get 2y minus 1. Shift 2y minus 1 on the other side. You get minus sin x by 2y minus 1. Correct? And then further you can write this as minus of 1 minus 2y. You can cancel minus sign, right? And then you get sin x by 1 minus 2y. Let us see one more example, same pattern. Here it is. This part entirely is y, right? So we'll begin with that. This part is y. So you get y is equal to x raised to y. Correct? Take log on both the sides because you have the power there. So log of y is equal to log of x raised to y. Y will jump and come here. So y will come there. You get y log x. Now differentiate y with respect to x. So this becomes 1 by y dy by dx. And this is your UV rule. Apply the UV rule here. Solve it further. This becomes dy by dx. 1 by y minus log x is equal to y by x. Shuffle the terms. Cross multiply. So dy by dx will be equal to y square. This y will go up and this part will come down, isn't it? So that's your dy by dx. So I hope you have enjoyed the session on differentiation in this particular chapter. We have studied about continuity, we have studied about differentiability. We'll continue our one-shot series. So see you in the next session. Bye-bye. Until then, keep practicing and learn with top scholars.